Hello everyone. In this video, we are going to study about transform network and transform impedance. Laplace transform method are used to study behavior of network in S domain. Each circuit element is replaced with its equivalent S domain. The initial energy in an inductor or capacitor is taken into account by adding independent sources in series or parallel with the element impedance. It converts network with voltage and current signal that change with time to S domain to analyze actions of a circuit using algebraic techniques.
The table here shown summarizes transform circuit component for resistor, inductor and capacitor. When we have R, L, C connected in series, the equivalent transform circuit for a resistor can be shown as V of S is equal to I of S into R. For inductor, we have equation L S I of S minus L I of 0 minus. Equivalent transform circuit can be drawn in this way. When we have capacitor in a series circuit, we get equation as V of S is equal to I of S upon Cs plus V of 0 minus upon Cs with the equivalent circuit shown here. When we have R, L, C connected in parallel, then for the element specified, resistor can be represented as V of S upon R. For an inductor, equation can be given as I of S is equal to V of S upon Ls plus I of 0 minus upon S with the equivalent circuit shown here. And for capacitor, we can write as I of S is equal to C SV of S minus CV of 0 minus with circuit diagram shown here. Let us go through a numerical. If we have a circuit given here, obtain transform network for the given circuit for both loop and node basis. We have a circuit here and we need to find loop basis and node basis equivalent transform circuit. So for first element R1, we have R1 in case of loop. For second element C1, we have equivalent capacitor equation 1 by C1S plus V of 0 minus upon S. For inductor, we have this equation S L1 minus L1 I of 0 minus. For R2, we have R2. For R3, we have R3. For C2, we have again 1 by C2S plus V of 0 minus upon S. And for L2, we have SL2 minus L2 I of 0 minus. When the same circuit is to be drawn for nodal basis, R1 remains R1. Capacitor C1 is represented as this C1S plus C1 V of 0 minus. For L2, for a parallel circuit, we have transform network for inductor as 1 by L1S plus I of 0 minus upon S. For R2, we have R2 as it is. For R3, we have R3 as it is. For C2, we have C2S plus C2 V of 0 minus. Finally, for the last element L2, we have 1 by L2S plus I of 0 minus upon S. Here we consider initial voltage and current in the circuit. Now, when we have questions where we can consider initial voltage and current as 0 for inductor and capacitor, we need not have to assume these initial voltage and current. So we can straight away replace an inductor as S into L. For a capacitor, we can replace a capacitor as 1 by Cs. Let us go through a numerical. We all know this tabulation. R can be replaced by R, L into SL, and C into 1 by SC in case we have initial voltage and initial current for a given circuit as 0. If capacitors are uncharged and inductor current 0 at t equal to 0 minus, show that transform of current I of S is equal to 10 into S square plus 1 plus S plus 1 upon S square plus 1 into S square plus 2S plus 2. A circuit is given here and we need to prove this I of S is equal to for the given circuit. And here it is clearly mentioned that capacitors are uncharged and inductor current is 0 at t equal to 0 minus. So let us solve the question. We first of all transform the elements that are given in the circuit. We have source here as 10 into sine u of t. We replace it as 10 upon S square plus 1. 1 ohm remains as it is as 1 ohm. 1 farad is converted into 1 by SC. 1 Henry inductor is converted into 1S and 1 ohm remains as it is. So, if we solve series and parallel for this particular circuit, we can write equation as 1 ohm and 1S are in series, which are in parallel with 1 by S and again in series with 1 ohm. So, on solving this series parallel elements that are available in the question, we get Z total as this equation, S square plus 2S plus 2 upon S square plus S plus 1. We all know according to Ohm's law, I of S is equal to V of S upon Z of S. We already have Z of S answer. We have already found out Z total. We know V of S, that is 10 upon S square plus 1. Substituting all the given values in I of S equation, we get this and the question is hence proved. Let us go to one more question. If capacitors are uncharged at t equal to 0, show that transform of generator current I of S is equal to S into S plus 2 up into 5S plus 6 upon S square plus 4S plus 13 into 10S square plus 18S plus 4. So, question states that capacitors are uncharged. We need to prove this equation for the given circuit. So let us transform the circuit elements first. we have source here as e power minus 2t into cos 3t u of t. We convert it as s plus 2 upon s plus 2 whole square plus 9. 2 ohm remains as it is. 1 by 2 farad gets converted into 2 by s. 1 farad into 1 by s. 1 by 2 farad into 2 by s. 1 ohm into 1. It remains as it is. We find equivalent impedance for the given circuit. 1 ohm and 2 by s in parallel, which is in series with 1 by s, which is again in parallel with 2 by s, and again in series with 2 ohm. So on resolving this equation, we get Z total for the circuit as 10s square plus 18s plus 4 upon s into 5s plus 6. According to Ohm's law, we know I of s is equal to Vs upon Zs. Substituting the values of V of s and Z of s, we get this particular equation, and the question is hence proved. Thank you.